2014 Civil Engineering Set 2 Question 53. A pre-timed 4-phase signal has critical lane flow rate for the first 3 phases as 200, 187 and 210 vehicle per hour with saturation flow rate of 1800 vehicle per hour per lane for all phases. The lost time is given as 4 seconds for each phase. If the cycle length is 60 seconds, the effective green time for the 4th phase needs to be found in seconds. The relevant NPTEL reference is mentioned. So when we talk about the design of a signal using Webster's method, the cycle length is given as 1.5L plus 5 divided by 1 minus the summation of the critical flow ratios. Here the cycle length C0 is the optimum cycle length in units of seconds, capital L is the total lost time in seconds, YC is so YCs are calculated as YC1, which will be equal to the critical flow in one phase divided by the saturation flow. Similarly, YC2 would be Y2 by S, and similarly for all the phases these critical flow ratios 1, 2 and so on are added to get this term. In this case it has been given that the signal is of 4 phases and the lost time in each phase is equal to 4 seconds. So the total lost time would be equal to N into L, that would become 16 seconds. It is also given that the cycle length is 60 seconds. So using the equation of Webster method, that is 1.5L plus 5 divided by 1 minus the summation of the critical flow ratios, we would get 60 equals 1.5 into 16 plus 5 divided by 1 minus the summation of the critical flow ratios. This would give us 1 minus summation of YC as 29 over 60. Using this we would have the summation of the critical flow ratios as 0.5166. The summation of the ratios would be equal to Y1 plus Y2 plus Y3 plus Y4 divided by the saturation flow, which is 0.5166. So the flows are given as 200, 187, 210, and for the 4th phase we don't know the flow, so that will remain as Y4. The saturation flow is mentioned in the problem as 1800 vehicles per hour. So substituting that value here, which is equal to 0.5166, the value of Y4 would be obtained as 333 vehicles per hour. Using this, the effective green time for the 4th phase can be obtained as Y4 by the summation of the critical flow ratios into effective cycle length, that is C0 minus L. This is in line with that we are taking the flow ratio, dividing it by the sum of the flow ratios, and then the total effective green time in the signal is being taken and being split to each of the phases. So Y4 was obtained as 0.185, 333 by 1800. This will be divided by the sum, that is 0.5166, which was obtained here, and this will be operated with 60, that is the cycle length, minus lost time, that is 16. This would give the value as 15.76 seconds, which can be taken as 16 seconds for the 4th phase. So the effective green time for the 4th phase is 16 seconds. The relevant NPTEL reference is cited.